Hi, mathletes. Today we're going to identify quadratic patterns in visual sequences. We're going to use visual reasoning and algebra to model growth. So in this video, you will analyze visual patterns to recognize how figures grow. You will discover how to model these patterns using algebraic expressions. And you'll develop a rule that represents the relationship between the figure number and the number of units. You'll connect visual thinking with quadratic functions in a meaningful way. So by the end, you'll be able to describe and predict growth using a mathematical rule. So here are three figures, and what are some of the patterns that you see? Again, you might want to pause the video here so that you have some time to look at them. When you're ready, just resume it and we'll see if we agree on our patterns. Welcome back. So here's what I see. I see that figure 1 has 2 squares. Figure 2 has 6 squares, and figure 3 has 12 squares. Something else that I see that the pattern is not increasing by the same number of squares. In other words, this one increased by 4, and this one increased by 6. I also noticed that the number of squares in figure 1 is the figure number multiplied by 2. So 1 multiplied by 2 is 2. I noticed that the number of squares in figure 2 is the figure number 1, so your 2 squares, plus this figure number multiplied by 2. So 2 multiplied by 2 is 4, plus the 2 here is the 6. And the same is true for figure 3. It's figure number 2, so you have the 6 of them, and you add that to the figure number 3 multiplied by 2, which is 6. And the sum of 6 and 6 is 12. So I could write that like the figure number 1 is 1 squared plus 1. There's my 1 that I added, and the 1 squared. Figure number 2 is 2 squared. There's my 2 squared, which is the 4, plus 2. And figure number 3 is my 3 squared, plus the 3. So what I'm squaring is in the red. So let's write a rule to find the number of squares for any figure number. So we can say that the number of squares equals the figure number squared plus the figure number. Now let's write this using variables. Let n equal the figure number. So we could say the number of squares equals, instead of figure number, I'm going to say n, so n squared plus the figure number n. Now let's verify or check that our rule is correct. First, we start with a given. So we're going to choose figure number 2. And in figure number 2, n equals the figure number, so n equals 2. So we will replace n with 2, so 2 squared plus 2, and 2 squared is 4, and the sum of 4 and 2 is 6. I draw it, and let's count to make sure that we have 6 squares. 1, 2, 3, 4, 5, 6. Again, here is the figure number squared, 2 multiplied by 2, plus 2 more. Now let's try one that's not given. In this case, we're going to try figure number 5. For figure number 5, again, n equals the figure number, so the number of squares should equal n squared plus n. I replace n with 5, so 5 squared plus 5, 25 plus 5, and the sum is 30. So therefore, if I draw it out, I should have my 5 by 5 squared, because that's the figure number, which is 25 plus 5 more. Let's count it to make sure that it's 30. And I'm checking. And sure enough, it counts up to 30. So I verified in my drawing, I counted the 30 squares. So what have we done? Well, we observed how visual patterns grow and change. We identified that the growth pattern followed a quadratic trend. We developed and tested an algebraic rule, n squared plus n, and then we verified our rule using multiple figure numbers, a given and a not given. So by connecting visual reasoning with algebraic thinking, you've gained insight into how quadratic functions model real patterns and help us make accurate predictions. If you liked this video, click the like button, leave a comment, and if you haven't subscribed yet, make sure you do. And as always, thank you so much for watching.